give you a brief introduction of what we do and how what we do fits with OpenNebula, and also give you an intro of a solution we did for a customer. Describe the use case, describe why they needed certain things, and how we achieved them. So, some background. The way I'm trying to present this is from the view of the customer, right? So here's the situation. They're a global brand financial institution. So you know the brand, but I can't tell you who they are, right? I'm sure you know the brand. It's actually in companies like this, these are like huge companies, you're actually not talking to the company, right? You're talking to a person in that company. In our case, we're talking to the head of the IT department of that company in its Middle Eastern branch. So it's like the local head IT person, right? They have an environment running VMware, an EMC and data domain and all kinds of good and expensive stuff, right? And they're just starting, they're just dipping their feet into a KVM-based virtualization environment. And they're not going straight to production with it, they're going into like a testing and development environment first, and maybe a year later they will start putting production workloads on it. When they came to us, they were looking at Red Hat Enterprise Virtualization and OpenStack with a bit of nudge from our side. We managed to convince them to use OpenNebula instead, right? They were also looking at some other kind of storage solutions, and they got convinced that the combination of OpenNebula and StorPool is the right choice for them. So how does StorPool work with OpenNebula? There is a storage plugin. So in OpenNebula, you have data stores. You could have some of these data stores on StorPool, right? So this is, you can think of it as two levels. One level is, there is the API integration, which means that when OpenNebula wants to create a volume, it tells StorPool to create a volume, right? When OpenNebula deletes a volume, it tells StorPool to delete the volume. And then there is also the kind of the storage data path, which is something that OpenNebula doesn't touch directly. So StorPool kind of attaches to each of the hypervisors to provide access to the actual storage devices underneath. So customer requirements, they were looking at, they came and said, we want a DR solution, right? And what we thought that means is you have two sites, virtual machines in one site, and then one site goes boom, right? And what you want to happen in that situation is you want the virtual machines to start running in the other side, right? Preferably without losing the latest writes, or only with losing some kind of short period of time of your production data, right? It turns out the requirement is a lot more kind of fine-grained, a lot more nuanced. There are a lot of things that we didn't think of initially. Like when they said, we want a DR solution, this is what we thought. Primary side dies, we start the VMs in the backup side, period. That's the whole DR solution, right? Turns out it's a lot more complex. So they want two sites. They want these two sites to be completely independent of each other. You can't have like a cluster solution being spread across the two sites. So you can't have, for example, you can't have a MySQL cluster with a master in one side and a slave in the other side, and then when the primary side dies, you promote the slave. That's not allowed. It's not their vision of what a true separation of the two sides means, right? Means you have two separate storage systems. You can't do, for example, you have some magical storage technology underneath that gives you a shared storage system across the two sites. And then, on top of that, if one set of hypervisors dies, you can start the VMs in the other side. This is not allowed because it's one large storage system underneath. If something happens to that one storage system, the whole service fails, right? So you need to have two separate storage systems. And you need to have separate networking. This means these both sites are connected to the internet over different providers, different routers in different data centers, different locations. It's not one large network that they're connected to. Then, kind of maybe the most surprising part of the requirement was they're not only looking at what happens if the whole primary site dies, right? They want the ability to migrate virtual machines between the two sites one by one, right? So you can think of, primary site has 1,000 VMs. 20 of these VMs rely on some underlying service, rely on some network connection which is available at both sites, right? And the instance of that in the primary site dies. They want to take just these 20 VMs and move them to the DR site. They don't want to move the whole primary site, okay? And then the most obvious one was, the whole primary site explodes and you start VMs in the other site. It took us about a week of going back and forth with them to figure out that this is what they want, right? If we haven't done this exercise with them, if we haven't figured out exactly what they mean when they say we want a DR solution, we would still have thought this is what they mean, and this is not what they mean by when they say DR, right? How does the solution look like? This is a very kind of hardware-oriented diagram. So you have storage nodes, 3 or more, in one side, and in the other side, two network switches or more, 3 hypervisors or more, and 2 OpenNebula controllers. All on separate physical machines. At the end, they actually decided that they want the storage nodes, the storage function, to be performed by the hypervisors. So it became a hyper-converged solution. But it's the same thing. So it's like, one way to think of it is you take this diagram, okay, and you fold it across this line. So you take the storage nodes and you fold them on the hypervisors. And it does the same job. You run both the virtual machines and the storage system on the same servers there in the middle. Then more, I think the technologies involved in this are OpenNebula with federated identities. So what does this mean? This is your trusted OpenNebula panel, which most of you kind of saw this morning. And in this panel, you obviously have instances and storage systems and network, and under infrastructure, you have hosts, etc. The part where you didn't get to is that this is one of the sites up there. It says one master in the corner. And you can actually go and select a different site. Okay? So this means you have the same kind of the user database of OpenNebula in the primary site and OpenNebula in the second site is identical. It's kind of replicated from one site to the other. Which gives you capabilities like the same user can own virtual machines. They can have control over the same some virtual machines in one site and some virtual machines in the other site. And then with users and groups, etc., you can do kind of assign resources to a project or assign resources to a particular department, etc. Right? This is OpenNebula Federated Identities. A level lower, the way it works is that you have 2 completely separate OpenNebula controllers, MySQL databases, and the only thing that's replicated between the 2, it's not the whole database that's replicated, right? It's just the user's table between the 2 databases that's sent from one to the other. That's the only thing that's connected between the 2 clusters, sending the user identities from one to the other. Okay? So this is one of the levels. What this gives you is from kind of end user experience standpoint, the end user, they log into any of these OpenNebula controllers. And then they, just by picking the menu and without having to enter the users and passwords again, they can go to the other sites that are with like separate OpenNebula controllers. Okay. Nothing new here, it's just existing functionality in OpenNebula. It's called federated or federation or federated identities, right? The other thing we have a StorPool cluster in each site, and we have StorPool site-to-site transfers. StorPool cluster in each site, it's a quorum-based system, meaning if you have 3 nodes, you need 2 of them in order for the storage system to process storage operations at all, in order to prevent split brain. We have 2 of these StorPool clusters. Each one of them has like an API for control of everything that touches that StorPool cluster. Then StorPool site-to-site transfers. In StorPool, you can take 2 clusters or more and connect them to each other over like a slow and insecure network. So we do like a connection between the sites, which is authenticated and encrypted. And then you can go to one of these locations and create a snapshot and send that snapshot to the other site. Okay. This is in a way similar to something called ZFS send for those of you who've seen ZFS. So you can create periodic snapshots in one site and send these snapshots to the other site. And then the last part of the whole solution is software we wrote specifically for this solution. So it's something that, like a new piece of software that talks, like it is split in 2. So there is like half of it is working in one side, the other half is working in the other side. And in each of the sites, it talks to OpenNebula and it talks to StorPool. How is it used? So this is the primary site. In the primary sites, you have instances, virtual machines, okay? And from like a user, what the user does is they select a few virtual machines and they apply a label to them. And that's all they need to do in order to enable these VMs to be backed up, right? So the kind of clever or good part with OpenNebula is it's very extensible. So you don't, we didn't need to, at the end, we didn't modify upstream OpenNebula to achieve this. So there is a standalone system which sits outside of OpenNebula and looks for virtual machines that have this backup, and then does certain things like create a snapshot periodically and send it to the other site. And other things that it does. So this is the GR site. In the GR site, so in the primary site, you mark the virtual machines. These are the virtual machines to be to have the GR functionality enabled. In the GR site, you get templates which correspond to the VMs in the primary site. If you instantiate one of these templates, so if you make a VM out of one of these templates, the data you will get underneath that will be the last available snapshot for that VM, right? And it's, again, it's all stuff that works outside of OpenNebula. So in terms of kind of functionality, I'll just scroll back to functionality number 2, ability to migrate virtual machines between sites. So this one I didn't explain on, in terms of user experience there. So you have 2 different use cases. One is if there is a disaster in the primary site, you want to start the VMs in the other site. When that kind of thing happens, you will lose some of the data. You will lose, say, the last minute of writes, or depend on how often we do snapshots. However, as a user of the system, there is another way. So as a user of the system, you can decide, I want to move like by command of the user, not because there is a disaster. The user comes in and says, I want to move my virtual machine from one side to the other, right? So in order for that to happen, as well as the GR, you need the same kind of network connections at both sides. And in this case, what we managed to do is what we do today is we suspend the virtual machine in one side, move all of its kind of latest changes from one side to the other, and we resume it in the other side. This means that you don't need to reboot the virtual machine, so you get like a few seconds of suspended state of the virtual machine, and then it respawns in the other side. We have the architecture, so we know of a way to do this completely live, right? So there is some additional work needed on our side, but there is a way to make this live, which is we have a site in Sofia and a site in Frankfurt, and you can live migrate a VM from Sofia to Frankfurt, right? Obviously without data loss. That is possible. So the state we've gotten this to is suspend, resume from one side to the other, with a fairly short interruption. I think when you tested it, a few seconds. So it's a few seconds. So if you, for example, if you ping the virtual machine, what you would see is you would lose 2 of the pings when we move a virtual machine from one side to the other on command from the end user. So this is where is it? There it is. So I think from the bottom line is OpenNebula is very easy to hook into, to extend. So it was possible for us with maybe 2 weeks of development effort, something like that, to develop a solution that sits outside of OpenNebula. So it's not patches, right? It's not we went in and made changes to the system. To develop a system that sits outside of OpenNebula and provides this kind of functionality, right? So gives you, it recognizes labels when you attach a label to a virtual machine, creates templates in the second side, copying all, say, the network configuration and everything that goes along with the virtual machine, and also hooking into, so in the second side, when you instantiate this template, there are hooks in OpenNebula for all kinds of kind of actions. So in this case, we're using a hook so that when that VM is instantiated, it actually refers to the latest snapshot. It doesn't refer to some older version of the data. So bottom line is very extensible. It's possible with fairly small amount of effort to achieve great, a lot more, right? Yeah, so I'm open to questions. Just ask away. Yeah.
First question. What is the practical frequency of making snapshots for this scenario? VM snapshots.
Depends, unfortunately. So we have a kind of, you can do snapshots on a schedule, which says every hour we will create a snapshot and we'll send a snapshot. We can also do snapshots on what we call a closed loop, which means create a snapshot, send that snapshot. When the transfer of the snapshot completes, create a new snapshot, right? In the second mode is very kind of very sensitive to the workload. So if you have more data to send, it will take more time. And I don't know what's a practical time frame. So if you have like a very loaded StorPool cluster, if the link is not fat enough to send the data over, it could be minutes. If it's low load, like most setups we deal with, we consider most workloads we see for us are low intensity workloads because our storage system is capable of so much, right? Tony, like with idling virtual machines, it's capable of doing it once every 10 or 15 seconds, I guess. Yeah, once every 20 seconds. Going through the loop of create snapshot, send it, create snapshot, send it. Right. With more workload, could be minutes, right? it will be a few minutes old, or if it's higher load, it could be 10 minutes old, right? Yeah, but I think to give you to know exactly how much it would be, you would need a real workload and a real system. Otherwise, it's just guessing.
And the second question, you said that you have developed a software for this specific deployment for this specific customer, but do you have production quality software that can be used for copy images between StorPool clusters?
The site-to-site functionality is part of our standard release, right? So what we still consider, right? So what we still consider custom work because it hasn't been deployed yet at 10 customers, right? We did it for this first use case, for this first customer, but we think kind of the requirements we gathered from them, they're fairly generic. We think a lot of people will have very similar requirements, so we think we'll be able to sell this, to deploy this to more customers. The site-to-site stuff is part of the standard release. So kind of the new things coming out are site-to-site functionality and iSCSI support for VMware. We're looking at support for Windows soon, and things like that. New stuff.
When you mentioned when you said that it's working on a snapshot base, does this mean it follows some kind of a chain pattern? Like how is it storing data? You have data, you make a snapshot,
Mm-hmm.
then you have new data, you have another snapshot. Does this mean that it has to follow some kind of a chain policy like Windows?
So
Or just
yeah,
combines the data?
you would kind of collect all the snapshots. So there is a chain of snapshots. So if you do, there are two use cases for snapshots. One is backups. In the backups use case, what usually happens is you have the live virtual machine, and then you have a long chain of old snapshots of that virtual machine. One an hour old, and one 2 hours old, 3 hours old, etc. Right? Which is chains, right? The other use case for snapshots is snapshots and clones. So you have a base image, and then you create lots of virtual machines out of that, which is fan out instead of chain. We support both, obviously. The way we support them is StorPool has a copy on write format that we use to store data in the underlying drives. So creating a snapshot is free, basically, meaning it doesn't kind of consume additional resources. Creating a snapshot means the new write operations coming to this volume will go in a different place, right? So they will not be mixed with the old writes, right? It doesn't kind of create anything special. Then on your last question, when you have a chain of snapshots, in StorPool, you can delete you can select an arbitrary snapshot and delete it. And when you do that, this means merging data between different layers. The way that works in StorPool is it only changes the references. It doesn't actually read and write data. It doesn't copy the actual data. It just changes the references to data. So it's a metadata only operation, right?
And doesn't delete the snapshots below? Like if you
Yeah.
delete the snapshot
Yes.
in the middle?
Every snapshot is on its own. If you delete the snapshot in the middle, it would take the data of the snapshot and merge it into the snapshot above it, towards where the volume is, right? One last thing, so for the site-to-site transfers, in order for this to be efficient, so if it's the first time you're transferring this image, it will have to copy all the data, right? If you have an older snapshot of this volume, an older snapshot of this image, it would copy just the differences between this new snapshot and the older snapshot it has. And it only requires that the destination storage system, the destination StorPool system, has the older snapshot. You don't need to keep the older snapshot in the source system. In some other storage systems, you need to keep it both in the source and the destination, right? Failback, when you have, yep, we have. But when you have, where is it? There is ability to migrate virtual machines between sites. So failback is the same thing, meaning you can go to the, if both sites are alive, primary and DR, you can go to the DR site and select the virtual machines you want to move to the primary site and move them, which is a suspended. Yeah. Sus- yeah. Yes. Just the differences. So the way it works is you can think of like snapshots and clones are like a tree, and as long as you're extending an existing tree instead of creating a new one, you're copying just the differences. So you have like a chain of snapshots in the primary site. Disaster, you go to the backup site and you branch off that chain and create a new VM and start branching off to the side. When the primary site comes back, you can attach that branch to the primary site, right? So it's failback is also like you don't need to copy all the data, and failback is without losing data, which means it's just suspend of the VM in the other site, resume the VM in the primary site, just a few seconds of unavailability, right? Not rebooting, right? Okay.
One thing you didn't mention, I guess it's assumed that both sites have to have exactly the same network configuration.
Yeah, correct. So you need, in terms of OpenNebula, you need networks with the same names and data stores with the same names. And we recognize them by name at the moment. So they, yeah. So if, for example, if you're doing live migration, like a migration of a VM from one site to the other, you can't have a different set of IP addresses in the other site, right? If you're instantiating, then it's possible to have a different set of addresses. So if you go from, where is it? This is the GR site. These are templates based on VMs from the primary site. When you instantiate one of these, it could be completely different set of addresses. So the only requirement is that there are networks with the same names, because these templates kind of, that's how they find the networks.
These VM templates will copy the context of the original context
Yep.
of the templates
Yep.
in the VM settings.
I think Anton can answer that a bit better because he wrote it, but it's the same OpenNebula XML, or what is it called? With
Very close to the original
yeah.
XML.
So differences are
Difference is that OpenNebula accepts both the ID of the given resource or its name as string. So
if the original one referred to IDs, it needs to be yeah.
could have different IDs with the networks, but when you map them by the name match, they will use these networks.
And for example, as Boyan said, with IP addresses, for example, if the IP address is assigned by OpenNebula, then here these instances will have new IP addresses. But if they're assigned manually when they were created, virtual machines, they will be moved here.
They are assigned to the contextualization.
But the contextualization is copied also on the other side.
It's generated by the destination site.
Okay.
It's not
Yeah.
static.
You read the ARM backup mechanism is external to Nebula. What was the reason for that?
List of requirements. Where is it? There is requirement number 0 of the customer. We want to use unmodified upstream software. Right. That was one of the reasons. Unmodified upstream means it's CentOS 7 with KVM that comes with CentOS 7 or some of the official repositories, right? It's OpenNebula. It's not like a patched, modified version, local version of OpenNebula. It's upstream OpenNebula. Generally, it also helps us in maintaining this. So it's not a patch set for OpenNebula. It's just an external program that talks to OpenNebula over a fairly stable API, right? Yeah, it's not like a patch set that we need to maintain with every new version. Yeah, let's talk later. So the kind of something that I should mention. There is a GR configuration with OpenNebula, which is it's different to this one. So this one is two separate OpenNebula controllers. The only thing that's shared between the two are identities, just user identities, right? And there is a more common one, which is two OpenNebula controllers over a master-slave MySQL database, which has the same data in both sides. That kind of setup requires, it requires a shared storage system. Requires a storage system that is visible in both sides. So if you have like one controller with the master MySQL database and one set of hypervisors has access to a shared storage system, then you have second controller with a slave MySQL database, a second set of hypervisors, and it needs to have access to the. With these requirements, this cannot be two sites, right? But we have heard, and Javi will correct me here, that a lot of people are using an OpenNebula DR solution like what I described, which is with the storage system that spans both sites, right? We considered that it was kind of the first thing we offered to the customer. They didn't like it for various reasons. Yeah, so it didn't fulfill what they expected of it. Yep. Cool. All right. Well, thank you.